Have you ever wondered how electricity, an unseen and untapped force, powers our world? From the smallest microchip to the largest power plant, the science of electrical engineering is at work. Today, we'll explore this fascinating field, making complex concepts simple and understandable. Now imagine a river. The water flows from one place to another, right? That's similar to how electricity works. It's a flow of electrons, tiny particles that carry energy from one place to another. This flow is what we call an electric current, the lifeblood of all electrical systems. But how do we control this flow? Just like in a river, we use gates or switches. A switch can either allow the electrons to flow or stop them, turning our devices on or off. But unlike a river, these switches can operate at fantastic speeds, opening and closing millions, even billions of times in a single second. Moving on, have you ever questioned why your phone's battery lasts longer than your laptop's, even though they're both running on electricity? That's because of power consumption. Every device needs a certain amount of energy to work. The smaller the device, the less energy it needs. That's why a tiny LED light can run for hours on a small battery, while a giant screen TV would drain that same battery in no time. Now let's delve a bit into the realm of circuits. A circuit is like a road for electrons. They start at one point, travel around the circuit, and then return to the starting point. Along the way, they pass through various components like resistors, capacitors, and transistors, each performing a different function. Resistors slow down the flow of electrons, capacitors store energy, and transistors act as switches. And what about those mysterious symbols on circuit diagrams? They're just shorthand for the components in the circuit. It's like a map, guiding engineers in building or troubleshooting the circuit. But electrical engineering isn't just about understanding electricity. It's also about using this knowledge to solve real-world problems. Whether it's designing a more efficient power grid, creating a faster computer chip, or developing a new medical device, electrical engineers are at the forefront of technological innovation. To summarize, we've covered a lot of ground today. We've explored the basics of electricity, learned about switches and power consumption, and delved into the world of circuits and components. We've also seen how electrical engineering impacts our everyday lives, from the devices we use to the infrastructure that powers our cities. Remember, the world of electrical engineering is vast and ever evolving. What we've discussed today is just the tip of the iceberg. So keep your curiosity alive, and who knows, you might just be the next great innovator in this electrifying field.